All right, welcome back as we start chapter 4 of Mr. Lubis's mathematical magic lessons. Or should I say Mr. Lubis's magical mathematical lessons? I don't know. You guys figure that out. So, anyway, chapter 4, this is there's kind of two parts of chapter 1, or chapter 4. This is 4A. So 4A is polynomials, and this should seem semi-reviewed to you. Looking at the definition of a polynomial, this is what a polynomial looks like. And 4xy squared plus 3x minus 5 is an example of a polynomial. This polynomial has three terms. So this 4xy squared is a term, 3x is a term, and negative 5 is a term. What do you notice about the terms? Well, you should notice that the definition of term is that terms are separated by a plus or a minus. So there's multiplication here. That's still making one term. The terms come, or the next term comes, when it's a plus sign or a minus sign. So what do you notice about terms? Terms are separated by a plus or minus. All right, add or subtract polynomials, we simply add the like terms. So whenever we have polynomials and we're adding polynomials or subtracting polynomials, we just look for like terms. We can only ever add like terms, remember that. So examples of like terms, 7x, x, negative 2x, 21x, those are all like terms. 1/3 x squared, negative 2xy squared, 6xy squared, and xy squared over 2. Those are all like terms. So definition of like term. Like terms are monomials, meaning single terms. Notice there's no addition or subtraction in each of those, that contain the same variable raised to the same power. So characteristics, we're going to say can have different coefficients. Remember, coefficient is the number in front. However, they're going to have the same variables. And those variables are raised to the same power. So again, kind of like the definition. So examples of like terms, again, that's our word. We can say x, 5x, 9x. We can say 21y squared, negative 3y squared, and 2y squared. Or we could also say something like 5xy to the third, 10xy to the third, and negative 7xy to the third. Again, those coefficients, the numbers in front can be different, but the variables are the same. They all have x and y, x and y, x and y, and the powers are the same, all x to the first and all y to the third. Some non-examples. So if I had x squared, and x to the third, although they all have x's, they're all different exponents, so they're not like terms. I could say 5xy, 5xy squared, and 5x squared y. Again, not like terms. Again, the coefficients can be, doesn't matter what the coefficients are, but even though these variables are the same, they're all raised to different exponents, so they are not like terms. That's why those are non-examples. All right, as we go on and turn the page, we look at multiplying polynomials. So the first thing is distributing, and we should all be fairly familiar with the distributive property. And that is where we would look inside the parentheses, and inside the parentheses, there's nothing we can do because there's not like terms there. We have 2x and negative 1. They're not like terms. So therefore, to actually multiply this, we have to use the distributive property, where we take the number in front or the term in front and distribute it or multiply it to each term inside the parentheses. So I take the 4 times 2x and get 8x, and then I take my 4 times -1 and I'll get -4. Again, you do not have like terms here, so we are done. We just multiply that. When we look at number 2, same idea. There's nothing in the parentheses that I can actually do, so I'm going to take the x times 2x, which is 2x squared, and then the x times -1, which would be -1x. Again, x squared and x are not like terms, so you can't do anything else. And the last example for number 3, inside the parentheses, I don't have like terms, so I can't actually add them. I go start distributing the -2x times xy, which would be -2x squared y. And then I'm doing -2x times -5, so that'd be positive 10x. And again, we wouldn't have like terms, so we are finished. When we do have this is 2 terms times 2 more terms. We call those binomials times a binomial. Binomial means 2 terms. So when I'm doing a binomial times a binomial, you can either do double distribute or FOIL. If you remember the acronym of FOIL, it's up to you. FOIL stands for first, outer or outside, inside or inner, and then last. So what you're really doing is just cover up that 2 and think of, there's nothing you can actually, there's no like terms in those parentheses. So you take that first x and distribute it to the other 2 terms. So I'm taking my x times my x, which is x squared, and that also happens to be the f for first. It's the first term of each parenthesis. Then I have to continue my distribution. So I take x times the 3. X times 3 is 3x. That's where the outside comes into play. Those are the outside 2 terms. Then I cover up my x, and notice I have a 2 that I'd have to take to each of my 2 terms. So 2 times x is 2x. And again, that's where the I comes into play. Those are the inner 2 terms, the inside ones. And then my last one, I take the 2 times 3. 2 times 3 is 6. And that comes for L for last. Those are the last numbers in each set of parentheses. When we do FOIL, we will have to combine like terms. So there's no other x squareds, but we do have 2 x like terms here. 3x plus 2x is 5x plus 6. All right, try these 3 on your own. For number 3, again, this would be a FOIL problem. X times x is x squared. X times 5x is 5x. -3 times x is -3x. And -3 times 5 is -15. And when we add those like terms in the middle, x squared plus 2x minus 15. For number 2, it would again be another distribution or a double distribute or FOIL. 2x times 3x is 6x squared. 2x times 1 is 2x. -7 times 3x is -21x. And -7 times 1 is -7. Again, I have like terms in my middle. So I'd have 6x squared minus 2x minus 21x is -19x, and then I have my -7 at the end. Number 3 is a little tricky because remember, when you square something, it means to multiply by itself. So to multiply, I'm multiplying x plus 5 times itself. So I have to rewrite this as x plus 5 times x plus 5. That's your first step. The x plus 5 is what's being squared, so you have to write that twice, which now makes it a FOIL problem or a double distribute. So I'm doing x times x, which is x squared. X times 5 is 5x. 5 times x is 5x again. And then 5 times 5 is 10. Add your like terms. 5x plus 5x is 10x. So I'm left with x squared plus 10x plus 10. All right, now, other types of multiplying gets a little more difficult when we have a binomial, 2 terms, times a trinomial. So one way you can do it is you can multiply the x times all 3 of the terms. Again, kind of cover up the 2. And you can also then cover up the x and take the 2 times all 3 terms. So that's one way to do that. I personally like to do something called the area model when I'm multiplying anything above a trinomial. So if I have a trinomial times a binomial or a trinomial times a trinomial, I like to do the area model. So I'm going to show you what that looks like now. So for the area model, you make a rectangle. And I have 2 terms here, so I'm going to make 2 rows, x plus 2. And then since I had 3 terms for my second, I'm going to have 3 columns, x squared plus 3x plus 1. So that gave me 3 columns. And it's called an area model because you're trying to find the area of each box. So the area of this box here is x tall by x wide, x squared wide. X times x squared is x to the third. Here I have x tall, 3x wide would be 3x squared. X times 3x is 3x squared. Then I have x times 1, which is x. 2 tall by x squared wide, 2x squared. 2 tall by 3x wide would be 6x. And then 2 tall by 1 wide would be 2. Now the reason I like the area model is because I know I multiplied everything I needed to because all these boxes are filled in. Also, your diagonals should be like terms. If they're not, you got to double check your work. So now I look to add like terms. There's no other x cubes, so I have x cubed. Here are my x squareds, positive 3x squared, positive 2x squared would be positive 5x squared. Here are my x's, 6x plus 1x is 7x plus 2. All right, let's go ahead and try these other couple. So I have 2 terms times 3 terms. So again, I would do an area model. X minus 1, meaning I'd have 2 rows and 3 columns. X squared plus 2x minus 1. And so I'm doing x times x squared, x to the third. X by 2x would be 2x squared. X times negative 1, negative x. Negative 1 times x squared, negative x squared. Negative 1 times 2x, negative 2x. And negative 1 times negative 1 is positive 1. Be careful of those signs there. Again, I know I multiplied everything. Every box is filled in. And my diagonals are like terms, which is what they should be. So now I just go ahead and add like terms. There's no other x cubes. 2x squared minus x squared is positive 1x squared. Negative x minus 2x is negative 3x and plus 1. For number 2, same idea. 2 terms times 3 terms. So I would have 2 rows. And I'd have 3 columns. So 2x times x squared, 2x cubed. 2x times negative x, negative 2x squared. 2x times 3, 6x. Negative 4 times x squared, negative 4x squared. Negative 4 times negative x is positive 4x. And negative 4 times 3 is negative 12. Again, multiplied everything. Look at my diagonals. If they're not like terms, go back and check your work. In this case, they are. X squared is this diagonal, x is this diagonal. So I have 2x cubed minus 6x squared plus 10x and then minus 12. And again, if I'll do this number 3 then as the triple distribute. If you want to do it this way, you can take the x times all the terms. So x times 2x squared is 2x to the third. X times x is plus x squared. X times negative 5 is negative 5x. Then I have to take the 2. 2 times 2x squared is 4x squared. 2 times x would be plus 2x. And 2 times negative 5 would be negative 10. Now, again, I think this gets a little messy. And I mean, I think I multiplied everything I need to, but in the area model, you know for sure you multiplied everything if all the areas are filled in. And again, the area model is a little self-checking because the diagonals must be like terms, where in this distribution problem, I don't know whether my exponents are correct or not really. I just have to trust myself. So there's no other x cubed, so I'd have 2x cubed. I have 1x squared plus 4x squared is 5x squared. Then I have negative 5x and plus 2x would be minus 3x, and then my minus 10 at the end. So bottom line, obviously, if you're distributing, you're just multiplying. If you're multiplying a binomial times a binomial, I like to FOIL that. Okay, first outside, inside, last. If you really wanted to, you could do an area model for that. Your area model would just be 2 by 2, x plus 2, x plus 3. So you'd have 2 rows and 2 columns. So if you want to do an area model for that, go right ahead. However, I think FOIL is going to be much easier, or double distribute. However, when you do get to trinomials times binomials, again, trinomials means 3 terms times 2 terms, or trinomials times trinomials, I personally prefer area model and think it's much easier and faster. All right, enjoy.